Hello again, everybody. Got a really good topic for you today, but before we get started, here's a quick quiz to remember what happened in last class. What is a collection of many separate universes? All right, so now we are going to move over to our topic for the week. Are there aliens, and can we find them? There's good old E.T. Okay, so we're going to start this topic, and this comes from chapter 30 of your OpenStax book. We're going to start this topic talking chemistry. Why is chemistry important? This comes from section 30.2 of your book. Chemistry is important because it turns out that all life on Earth has the same basic chemistry. And so we start with what we know. We're going to hear that a lot as we talk about life in the universe. We start with what we know, what works for life, and then we see if we can find it elsewhere. So let's find out, what do we know about the chemistry of life on Earth? Well, it turns out that life on Earth is simple in one sense, and that is the sense that it is fundamentally made of just 6 elements on that periodic table. Remember when we were sitting in class, we looked at that periodic table, all of those different elements, over 100 of them, almost 200, but just 6 are really important for life. The big one is carbon. We're going to talk more about carbon, but also hydrogen, the most abundant element in the universe. Oxygen, that shouldn't be a big surprise, very important for humans. The next one is nitrogen. If you've ever done any gardening, you know nitrogen is really important for those plants. And then the last 2 are phosphorus and the last one is sulfur. Okay, so those 6 elements, and sometimes you'll see an abbreviation either just of the first 4 or of all 6 is what your textbook has. I don't know how you want to say that, schnapps, schnopes. But those are the 6 elements: carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. And here's like our little human body here, and you can see the various percentages of those different elements. It turns out that human beings have a lot of calcium because we have bones. But not all life has bones or calcium. And of course, there are other elements. Some of those others include things like potassium, magnesium, iron, other kind of things. Remember, those heavy elements and metals were made in supernova explosions that we talked about. Our DNA is CHON plus phosphorus. So that's the building blocks of us and of all life on Earth. But let's talk a little bit more about carbon, because we generally say that life on Earth is carbon-based. Okay, so life, even though we talk about those 6 different elements, is based on carbon. What we mean by that is this atom, there's your carbon atom, is the backbone, is the structure on which we build our DNA and our other proteins and special molecules that are important for life. Why? Because it's special. Carbon is a very special type of atom, and we're going to talk about a couple of its properties that make it really useful for life. Okay, based on carbon because it's special in a couple of different ways. Okay, so special. Why is it special? One main way that it is special is carbon is tetravalent. Tetravalent. What does that mean? Okay, it's been a while since I've been in a chemistry class. You're not in chemistry either. Tetravalent means that it has 4 bonding spots. So carbon is tetravalent. That means, and here are the properties that make it important. It has 4 bonding spots for other atoms. And you'll see in my picture here, those other atoms are hydrogen. We have 1, 2, 3, 4. That makes it really flexible. Different atoms have different number of places to put bonds. 4 is a really great number. It turns out tetravalent. Tetra means 4 and valent is that bonding. Because with 4 spots, we can form chains. And that's really what is important. It forms chains of atoms, like in the picture here, to make these long molecules that we like to call proteins. And proteins, right, you get your proteins by eating meat or maybe beans, but proteins are very, very important to life, right? And you can't get a protein unless you get a chain. And what's the best kind of atom to make a chain? Carbon. So you can make chains out of different atoms, but it's much, much more difficult, and not all atoms make chains. So we think that life, maybe even beyond Earth, could also be based on carbon. Let's look quickly, though, at one other atom that makes chains that's also tetravalent and compare it to carbon. So this other atom is silicon. Okay? And this is another one that people have speculated life might be based on elsewhere. So why? Because silicon is also tetravalent. So it has 4 bonding spots, which means it can make chains. But the problem with you can see in my little cartoon here, is that it's heavier. But it's a heavier atom. And it also is harder to bond. It's got those short little arms. So this heavier atom has a problem in that it can't form chains that are as long and as robust as carbon. So it can't form chains as long as carbon chains. And we have some long chains, long proteins in our bodies. Silicon's just not that flexible, okay? However, it does have one advantage over carbon, and that advantage is that it is more stable, meaning it won't easily break up at higher temperatures. So it's more stable than carbon at higher temps than carbon. So this is kind of cool because if we can imagine a planet that's hotter than Earth, where it's hotter all the time, maybe silicon is a better choice. Because when things get hot on Earth, they tend to melt, burn, etc. You've seen carbon, charcoal, ash, right? Silicon does a little better than that. Silicon, think glass. Right? Glass has a lot of silicon. It does better at high temperatures. So it's an interesting possibility. Here is one artist's imagination of what a silicon life form might look like. But in general, we think that life forms are likely carbon, but it's possible that they are not. Okay, so life forms that are not carbon-based may be possible. We just only see carbon-based on Earth. Life forms that are not carbon-based are possible. And so this artist imagined a silicon-based life form, maybe more crystalline in structure, if you sort of think about glass. Maybe on a planet that orbits close to its star, so it's hotter. Could be really interesting. Fiberglass might be a flexible, kind of weird, filmy thing. So that's kind of something just to think about, food for thought today. What would life look like if it wasn't carbon-based? We don't know. We haven't actually experienced that. So that's a little bit on the chemistry of life. Here is your clicker question, which is not one of those 6 elements. So you can answer that on Moodle, and I will see you in the next video.